Hello and welcome to this IB Maths Intense session, number 5 on exponentials and logarithms. This time we're looking at the laws of logarithms, having just had a look in video number 4 about what a logarithm exactly is. It's now important that we understand the laws of logarithms in exactly the same way as we needed to understand the laws of exponentials. And you'll see that the laws of logs really behave in exactly the same way as the laws of exponentials. Let's just go through them very quickly, and then in the next video I'll do more examples of how we use those laws of logs to solve, evaluate or simplify expressions. But let's just go through the laws so you've got them all and you understand how they work. The first important law is the logarithm of a product can be expressed as the sum of the logarithms. So there's the expression log to base a of xy can be written as log to base a of x plus log to base a of y. Let's give you an example. So, for example, if I had log to base 5 of 50, I can think of 50 as a product. It's 2 times 25, for example. So I could rewrite it as log to base 5 of 25 plus log to base 5 of 2, because 2 times 25 is 50. Now, hopefully you can see that that gives me an opportunity there to simplify some of that, because log to base 5 of 25 is 2, and then I've got log to base 5 of 2. So log to base 5 of 50 is 2 plus log to base 5 of 2. So this gives me a great opportunity to simplify things. I can also work back the other way. I could say log to base 4 of 8 plus, for example, log to base 4 of 2. And I might want to bring those two together. They're both the same base. And that's important. I can only do this if the base is the same. So I can combine them. And I get log to base 4 of 8 times 2, which is 16. And now I've got log to base 4 of 16. I can evaluate that because 4 squared is 16. So log to base 4 of 16 is 2. So we can work either way with that particular law. And when we're dividing, so the logarithm of a quotient is the reverse. It's the difference of the logarithms. In other words, we subtract this time. So rather like with the laws of exponentials, when we divide, we subtracted the indices. So again here, let's give an example. I could have log to base a of, for example, 125, log to base 5, let's make that just so we can evaluate it. Log to base 5 of 125 divided by 3. I can split that out and make it log to base 5 of 125 minus log to base 5 of 3. And you'll see that log to base 5 of 125 is 3. So I end up with 3 minus log to base 5 of 3. Fantastic. I could work the other way, and I could, for example, say log to base 3 of 540. I could find a way of expressing 540 as two numbers. Let's see. Let's make that log 540 minus log to base 3 of 20. I can now bring those together into a quotient. So I can end up with log to base 3 of 540 over 20, which is log to base 3 of, or 540 over 20 is 27. And hopefully you can see that 3 log to base 3 of 27 is 3, because 3 cubed is 27. Here's just an interesting result that leads us to another law of logs. Imagine I had log, let's keep it to base 10, log to base 10 of a half. Well, using the same rule that I've just had, this would simplify or could be split out to be log to base 10 of 1 minus log to base 10 of 2. But hopefully you can see that log to base 10 of 1 is 0. Because 10 to the power of 0 would give me 1. So log to base 10 of a half is actually minus log to base 10 of 2. Log to base 10, in fact, log to any base of 1 always gives 0. And that will lead us to the next law, which is the logarithm of a reciprocal is always the negative of the logarithm. So if I had log to base 5 of 1 over 30, it's just going to be minus log to base 5 of 30, because log to base 5 of 1 is 0. So using the previous rule, I would have got rid of log to base 5 of 1 and replaced it with 0. Nice easy one. Now if we're taking the logs of an exponent, so this time we've raised something to a power, we get a result that is the multiple of the logarithm. Let me show you what I mean. So if I had log to base 4 of 15 squared, I can get rid of the exponent and bring it to the front of the log. So it's 2 log to base 4 of 15. And that kind of makes sense because if you think about it, log to base 4 of 15 squared is a product. It's a log to base 4 of 15 times 15. And the earlier rule we had that said when we had a product, we could split that out, and that would have been log to base 4 of 15 plus log to base 4 of 15. And that would have given me the result I've got above, 2 log to base 4 of 15. So remember that, when the exponent, you just bring that to the front, and that makes things a lot simpler. Don't forget that all sorts of things can be expressed as an exponent. So if I had log to base 10 of root 2, that is, of course, log to base 10 of 2 to the power of a half, and then I can bring the half to the front. It's half log to base 10 of 2. So make sure you see the opportunity to get the exponent to the front there. And then the last link to that, of course, what I just said there, log to base a of 1 is always 0, irrespective of the base. It doesn't matter whether it's log base 37 of 1 is equal to 0, log of 999 of 1, log base 999 of 1 is also 0, etc. That's a nice, easy result to remember. And then lastly, a really, really useful rule. You probably can't think of an application for it now, but I'll show you in the following videos, is where we want to change a base. So, for example, I might have log to base 2 of 3, and I might decide actually I want to work in base 10. Maybe other numbers that I've got in my problem are in base 10. Well, to change the base, we always put on the top this number, log to base 10 of 3 over log to base 10 of 2. Okay, so we can change the base. Log to base 2 of 3 is the same as log to base 10 of 3 over log to base 10 of 2. It doesn't have to be base 10, any base you like. Sometimes it's useful to change to a base that enables you to simplify things. So, for example, if I've got log to base 5 of 10, I could write that in base 10, so that I end up with log to base 10 of 10 divided by log to base 10 of 5, just using the rule at the top. And I hope you can see that log to base 10 of 10 is going to be 1, because 10 to the power of 1 is 10. So I end up with 1 over log base 10 of 5, which gives us another interesting result that we can just put down here, that if I have log to base a of b, that can be rewritten, if required, as 1 over log to base b of a. That may be useful in the expression or the problem that I'm working with. Now, on the formula sheet, we're given 4 of those because the other 2 or 3 that I went through are just generalizations of the 4 that are on the formula sheet. So there you are. SL 1.5 gives you the general relationship between exponentials and logs, and SL 1.7 gives you the laws of logs on your formula sheet. So if you're a little insecure on them, you can't learn them, they are on the formula sheet, but I think you'll get to learn those and be able to use them without needing the formula sheet, just through familiarity. So next videos we will look at how to apply the laws of logs for typical kind of logarithm problems, solving, evaluating and simplifying. But I hope you found that useful. Thank you for watching. Don't forget to like this video and subscribe to my YouTube channel, IB Maths Intense. Tell your friends I'm here. And drop me an email at ibmathsintense@gmail.com if you've got any questions, suggestions, or if you found any errors in any of the work that I've been doing for you. But in the meantime, you take care and enjoy your maths.